this video, I'm going to show you how we can use Zero Trust security controls to lock down a Windows server that has a public IP and is facing the public internet. While that is a generally a terrible practice, you should not do that. You should not put a Windows server on the internet. I'm just going to show you the power of the Zero Trust capabilities of CoIP Platform to be able to lock this particular machine down and how quickly you can do it. Okay, so first of all, notice that I'm connected to the public IP of that machine, 18.144.63.241. That is in AWS. If I run a nmap on port 3389, you can see that the state is open. That machine is available for the entire internet to scan. And I'm sure somebody's scanning it right now. So let's go ahead and stop that. Okay, so what we're going to do is we're going to use CoIP Platform to block that. And we're going to want to keep the access available for users who are authenticated and authorized. So I'm going to make sure that that's available first. Okay, so I've already onboarded the server. You can see that I've actually downloaded the agent and installed it on that server. So it shows up here. If I double click on that, you can see all kinds of information about this, where it is. It's in United States, which cloud region it's in. All that information is gathered by our agent and used to as part of the identification for factors that help us to tell if a server appears to be spoofed or not, appears to be something other than what it claims to be. Okay, so these details are available to you, but I guess the point is that we want to make sure that that's onboarded and it's working. You can see here, status is agent is online. What I'm going to also verify is that I've created an access policy. I've already onboarded users through my identity provider and created a user role. And I've also already created an access policy. The access policy says I have a remote desktop access to this specific server. If I click next, you can see what kinds of access that I have. We have the VNC RDP. In this case, it's a Windows server, so it will be RDP that you have access to. Okay, so very simple. So now if I log in using our DNA launcher, it's basically browser-based access. And you can see that it's backed by an identity provider. So I log in. If I had configured multi-factor authentication, it would use that instead. Okay. Well, in addition to the factors that I used just now, which is basically just password. But if you have SMS or PIV key cards or hardware keys or whatever authenticator apps, whatever your IDP is using, you can use that to ensure that the people who are accessing the server are who they claim to be. Okay, so now I click connect here on that particular machine, and I'm prompted to log in. And because RDP only allows me to have one session to a machine at a time, that one is disconnected while this one is connected. So you can see here, let me shrink that again. Now I'm back. This connection to the public IP was disconnected. The connection to the local host 51.397. Now that's a port on my machine. It's a dynamic port. It's used only for the purposes of creating this connection. It's using an overlay connection to get into that machine. So there's actually no inbound ports that will be open as soon as I make this change. You can see that I haven't done anything yet to the ports, so that the 3389 is still open. You could actually go back in again, but that's what we want to close down. So we want to make sure that this stays open and then this goes away and stays down for good. Okay, so let's go back into the portal and go to our chamber policy. Chamber is a concept. Basically, you can think of it as an endpoint firewall, more powerful than just an endpoint firewall, though, in terms of what it can do. It's aware of identities. It's aware of policies that connect different objects to other objects. So it's a little more capable than a basic endpoint firewall. Okay. So here I've got some default rules. The rules say that I'm going to block and not log non-whitelisted inbound connections, and I'm going to allow outbound connections to the local network and the internet. Okay, so that if I turn that on to prevention mode here, you haven't seen that anything changed yet, but if I go into terminal and scan that machine again, you can see now this port state is filtered. So Nmap could not reach 3389. And just to show that, verify that, if I go back to the connection center here and try to connect to that machine again, you can see that it's blocked. So that server is hidden from the internet. And this connection didn't go away though. So it means that I can still use this. So let me show you here. Let me show you here that this connection is still usable. I can connect to Google. I can connect to internal services as well. So, okay, so that machine is available to me. It's something on the local internal network. If I want to lock that down even further, okay, I can change the setting of the chamber here so that I do not allow internet connections. I only allow outbound connections to the local network. Now, why you would want to do that? You'd want to do that if you want to prevent somebody from abusing this machine and using it as a staging point for exfiltration of data, what have you. So this is a very simple and easy control, allows me to prevent that. As soon as I click save, go back to my remote desktop window, still right there. Okay, so again, now I can still connect to the internal network, but if I try to connect to Google, you can see that's blocked. So now I can not connect to anything on the internet outbound from this machine, although I can still use it for my connection to the internal network, and it's locked down so that this machine cannot be accessed unless I have authentication and authorization to be able to do so. So I hope that really helps you understand how you could use controls like this to lock down applications with Zero Trust. And if you have any questions, please check out our website, zentera.net. Thank you.